What would David Beckham do in a situation like this? I know. Bang the nanny. Greetings, the Astro 30 here yet again on this 4-channel mixer project. Now, today I'm going to be looking at a balanced line output plus an unbalanced line output to add to this circuit, and maybe a headphone amplifier. It wouldn't really be complete without a headphone amplifier. Now, all of that is going to come before the master volume control, so the line out comes before the master volume, and so does the headphone amplifier, which would have its own separate volume control. Now, I was going to make a PCB up for at least the front end stage of the mixer, and I can still do that, but I thought no, I'm going to wait a week or so, because I've ordered some pots similar to this, 16mm, but with 18 tooth splines on them from Ultronics, which would look great, because I want to use these type of knobs on it because these look excellent on a mixer and guitar amplifiers. Just saying, some people like the dovetail type or chicken head knobs on amplifiers, like those style of knobs. I mean, yeah, they look okay. I'm not a big fan of them. And also, last episode I fucked up again, but you already saw the original fuck up I made, but in this case I made a big fuck up. That socket, which is connected to a guitar lead which was plugged into my bass, I actually had the ground and the signal wires swapped around, so I was actually grounding the signal wire and getting the signal off of the ground, which is why it was noisy as hell. I noticed that the other night when I was playing around with it a bit more and swapped the leads around, and most of the noise went away. Surprising that. I've also dumped the Class A module that was powering the speaker in favour of the LM1875 that I built previously, because this will run quite happily on plus minus 15 volt, just not at its full output power obviously, but it works a lot better than the Class A amplifier that was connected to it in its place. Right, so that's the plan. I'm going to build up a balanced circuit first for the line out, which would be plugged into an XLR socket. Right, so this is the circuit I'm going to be using. As we can say, it's op amp based, and this is basically from a DI box or direct injection box, and what that does is it takes an unbalanced input signal, usually of high impedance, and turns it into a balanced XLR output. And both the gains of these op amps are going to be exactly the same, a gain of 1 or unity gain, and it's really up to the device that it's connected to get the CMRR correct, or the common mode rejection ratio correct at its input, so that it's working as a balanced input correctly. It's not really up to me to do here. Now, what we're looking at is we've got one op amp connected as non-inverting in what is known as a voltage follower. That is basically a unity gain buffer, but it's non-inverting. Over here we've got our standard inverting amplifier, so that has a 10k resistor as the feedback and a 10k input resistor, and the formula is gain equals RF divided by R in, so that would mean, well, 10 by 10 is 1. So we both have two stages here producing a gain of 1. This one is in non-inverted and this one's 180 out, and this one drives the hot pin, which is pin 2, and this one drives the cold pin, or the inverted pin, which is pin 3, and pin 1 is ground. It's a very simple circuit. There's not much to it. The thing is, here they've got a 470k resistor here as the input impedance resistor, which is giving it its high input impedance, but for my purposes I don't need it to be that high. I can actually get away with a 22k there instead, because the part of the circuit that it's coming off of, which is the back-handle circuit, is already a low impedance path anyway. But I've drawn this up on a whiteboard a little bit better so we can see the, well, one change that I made. Okay, and here it is drawn up on, I was going to say breadboard, that'd be incorrect, on whiteboard. Still got the input signal over here. We're going through a 1 microfarad capacitor instead of a 0.1, and having a 22k resistor here as our impedance resistor. Everything else is relatively the same. All I've done is I've drawn our signal waveforms. Here's our input uninverted, here's the hot pin uninverted, here's the cold pin inverted. But even though it's not drawn to scale, all signals are the same level. So it's 1 to 1. Whatever comes in is whatever goes out. It's just one's inverted, one's not. And that's it. That's the circuit that I'm going to be using. We'll cover the non-balanced line out circuit a little later in this video, but first, time to build it up on a spare bit of breadboard here. I might build it up down here because it seems convenient. And put it on an oscilloscope and test it out. Penis. Alright, well, I've got the little balanced output circuit built down there. Got a couple of oscilloscope test leads to the 1k resistors at the output. The green one is on the inverting side, the yellow one is on the normal side, or the non-inverted side. Its input's hooked up to the output before the master volume control, and I've got the line level input at roughly half mast and pushing in 2 volt from the DDS. And it's still hooked up to the power amplifier, but I've got the master all the way down so we can't hear the annoying tone, which is, yeah. Anyway, we can see that with the line input control almost halfway, we're getting around about a volt out, because this is set to 1 volt per division, and the math on both channels there confirm that. And we can actually see one is going one way and the other is going 180 degrees in the opposite direction. But is it? So if I take my inverted test lead off the output now and stick it at the input, we can now see that both waveforms are the same. So definitely what is coming out of this inverted op amp is definitely 180 degrees inverted, as it should be. So I know that that's working. Well, that was well worth the effort, and for a simple circuit like that, you don't need very many components. And I'm going to move on to the next thing, which is building the, well, the, can't think of it, the normal line out, which is just a unbalanced signal. And I'm basically going to use a 1-to-1 buffer as well, non-inverting. Pretty much the same as the circuit here for the balance, just only building one side of it, because that's all you really need. So reference here is our normal line out circuit here. It's just a voltage follower, as this one is up here. We're just taking our output off of pin 7. Now I'm using another NE5532 as I am up here. Got the circuit built up on the breadboard there, so now I've got to move my green wire off of the, well, my green probe from there to the output of this one now. DDS still turned on to 2 volt per division 1 kilohertz. Power supply is off. Turn the power supply on and we should see relatively 2 waveforms the same phase. Well, I've done it again. Just like when I was first testing this balanced circuit, I forgot to connect a wire between pins 2 and 1 of the op amp on that side. I have forgotten to connect a wire between pins 6 and 7 on that op amp, and as we can see, no output. So I'm going to have to find a wire and correct that problem. Now it wouldn't be the Astro 30 video without making some form of mistake. So I need to go between 6 and 7. So these 2 pins here. Now we have an output. Look at that. And it's around about the same voltage as expected, 1 volt odd out. So there we go, we've got a normal line output in phase with the hot pin of the balanced. And if I just move my oscilloscope probe from that line out to the cold out, we now have an inverted signal like we're supposed to. So both those line out circuits are working. Very good. I haven't drawn up the schematic properly for it yet, but excuse me, I'm in just the process of playing with it and whatnot. Yeah, so just remember, if you're going to use a op-amp non-inverted in unity gain, remember to connect the output back to the inverting input. Just like when you're using an inverting amplifier, always remember to connect the non-inverting input to ground. Those are the two things with op-amps I tend to keep forgetting to do, is applying correct feedback and grounding the bloody thing. Anyhow, moving on. And just as a side note, which has nothing to do with this video, but I thought I'd share it anyway, I managed to find last night a copy on eBay of Directions in Groove, the favourite 3-track single CD, which features Clunky live, as played by Samuel Dixon on the bass, which is the track I have been playing on multiple videos here on my bass, which is the original version of the song that I've heard. The newer version from the 96 album. This one's 93, I believe. Yeah, it doesn't sound as groovy as the original one did. So I found that, so that should hopefully be here Friday. Man, it's hot as a motherfucker here. Currently reached 26 degrees. Alright, so here's my proposed headphone amplifier schematic. We've seen this before, except the only difference is I've drawn it as an inverting amplifier as opposed to a non-inverting amplifier. Using it as an inverting amplifier just means A, the signal is going to be 180 out of phase with the input, which is okay for headphones. It's not like you're going to really notice wearing headphones and coming out the speaker at the same time a lack of bass, because the headphones are closer to your ears than the speaker driver is. However, that aside, that just makes doing the circuit a little bit simpler, that where you don't actually have two extra components, a resistor and a capacitor, going to ground as you normally would off of the negative input to give you your gain. All we have is just a feedback resistor and this input resistor, and again the gain equals 220k divided by 47k, which is a gain of 4.6 roughly. I think it's about 4.613 reoccurring or something. But it's still the same sort of amplifier, using two transistors here and emitter follower as the output stage. Remember, this doesn't provide any gain, this just allows more current to go out to what we're powering, which is the load. Rather than connecting it directly to the op-amp, being self-biased by these two signal diodes, one in 4148s or one in 914s, whichever your choice. And this 10 picofarad capacitor here is just to provide stability to this op-amp at that gain. This 220 nanofarad capacitor at the input is just to cut a bit of the low bass that may be present on the signal line, like, you know, which may appear as a rumble, especially coming off like a bass guitar. You may hear a bit of rumble in the headphones, and it's not a very nice sound. So that just rolls off the bass a little. We'll have a look on the oscilloscope when I set it up on the breadboard what actually the frequency response of this is. So I suppose the next thing to do is to build it up on breadboard. No, only kidding, I am going to do it in this video. Okay, buggered if I know why, but the NE5534 refused to work in where this NE5532 is now. I'm not sure as to why, but for some reason I wasn't getting anything coming off of pin 6. Could have been this breadboard, I don't know. And I tried it in both non-inverting and inverting mode and got nothing. I even fried two of the 33 ohm resistors here because I disconnected these two diodes off of the output, so these transistors were no longer base biased anymore, and they heated up red hot, and then we ended up with smoke coming off the resistors, which would have been good on video, but I didn't get it. So I dropped in the 5532, messed about with some of the wiring to suit that configuration, and we have a fucking output. And that's the green trace at the bottom, that's our output. And I've got a 20k linear pot there as the volume control for it. As we can see, it's increasing. Now with the 2 volt peak to peak going into the preamp, it says I'm getting 2.85 odd volt peak to peak out, which doesn't seem like a lot. But this is unloaded, by the way. It's not going into a load as if it was connected to a pair of headphones or anything, so keep that in mind. But it is working as an amplifier, which is the whole entire point. So what I need to do is I need to load that output into a 68 ohm load. Well, I couldn't find a 68 ohm resistor. I thought I had one, it's disappeared. So I'm using a 33 instead. So I'll crank the volume up to its full. For some reason that seems to be interfering with the main output. Not sure why as to yet. We're getting about 909 millivolt peak to peak. Alright, so I've connected up some headphones across the output, and I'm going to rotate the control, see if I can hear the tone. Well, I can. Don't know if you can, but it's not very loud over here, but well, you don't really need it to be. It's just powering headphones. That's currently with that operating at a gain of 5.7 roughly. That's what I've got it to now. Suppose now we'll have a look at the frequency response of the output. Okay, well, we're pushing unloaded 5.145 volt peak to peak. It's not bad. As for having that loaded back into a 33 ohm, and I'll connect the resistor across the output. Yeah, we're getting more closer to a volt out. Actually 1.6 volt peak to peak. Okay. However, of course, that's not with the input of the mixer up to the point where we're starting to drive into distortion. So I've got the pot at maximum for the headphone. I'll just rotate the input. This is the input up here. We can see it's increasing, and it's really starting to distort there. And if I put this probe into times 10, it just stopped functioning. Yeah, right. Now we've got major crossover distortion. Right, well, I think I blew the op amp. Doing that, driving it into distortion, it popped it. Don't know why, shouldn't have done. So anyway, I'm averaging that this circuit's going to be producing around about 100 milliwatts thereabouts, which is okay. Apparently you can't crank it all the way up or you blow the op amp sky high. What a shame. Anyway, so that would actually complete the preliminary design stage. As I said, buggered if I know why the 5534 didn't work in that place of the 5532. Yeah, I'm shrugging. Doesn't matter. Just means I'll make the headphone amplifier on a spare channel of a dual op amp and leave the output amp, that one there, as a NE 5534. Ah yes, we were going to look at its frequency response, weren't we? Because of that input cap. I'm still in times 10 probe. There we go. Right, so I'm going to leave it about there. So I'm going to drop my frequency down to 60 hertz, thereabouts, when I can find the bloody thing. Where's the 60 hertz? And of course the screen went black. There we go. Well, we can't really see much, but it looks like, to me, if I go to 500 microseconds, that was the wrong way, make that 5 milliseconds. Yeah, that looks like to me that it's only dropped off about 100 millivolts or so. So if I go now to a frequency of, say, 100 hertz, voltage came back up again. So yeah, we're still going to get a reasonably good response. So I'll go into sweep mode. I might change the time base back to 1. And yeah, it looks reasonably flat. I can't see any roll off. We're about 1.1 volt, all the way between 20 hertz to 20 kilohertz. So the frequency response is reasonably flat of that headphone amplifier. And that was with it connected across my 64 ohm headphones there. It's across both channels, which would be 33 ohm loading. So I'll load one channel. Voltage came up a bit. Load both channels, yeah, it drops right off. So I'll just load one channel, don't need to have both done. So I'm just going to take that out of the noise that it's doing. I'm going to change the frequency back to 1 kilohertz. Yeah, so anyway, let's kill that. The design is working, it's coming on, and I can now move on to the next stage, which will be routing out the PCB for the input stage, and I can now start thinking about drawing up the schematic for the output section and mixer section, so that's ready to also be routed on a PCB. It's getting late in the afternoon and I'm hot, and I'm thinking about going off and doing something else for now, so I'm going to leave this video here. So if you enjoyed it, please remember to rate, comment and subscribe below, and you can always follow me on Facebook and Twitter. The links are in the description as usual. Anyway, this is the Astro 30 saying see ya. See you in the next part.